Assalamualaikum and hi. In this video, let's discuss about the Fourier series. Okay, we start with the definition of periodic function. As I told you in class, okay, during our synchronous class and at the first video, I told you about the Fourier series involve the periodic function. Okay, what is meant by periodic function? It is a function. Okay, it is a function f(x) which is defined over the interval x from negative L to L. Okay, and it is periodic with period 2L. Okay, period 2L. If your function f(x) equals to f(x) plus 2L. Okay, so 2L is the period. Okay, so when we have a periodic function, we will write the function as not only f(x) but f(x) plus the period. Okay, so the 2L is the period. Okay, so if we define the function from negative L to L so that your period is 2L. Okay, if you have for example the function is from negative pi to pi. Okay, from negative pi to pi. Let's take a look at this one. From negative L to L. From negative L to L. Okay, from negative L to 0, the distance is L. Okay, and then from 0 to L, you have another distance is L. So L plus L equals to 2L. Okay, so this function will be repeated. Okay, will be repeated with the same pattern, with the same shape of your waveform. Okay, over the same interval. So each time of 2L, you will get the same shape or the same waveform or the same pattern of your graph lah, saya kata macam tu. Alright, so now let's say, okay, if we try to compare with the definition here, okay, if you have from negative L to L, so that your period is 2L, so we write the period here so that your function, this one becomes periodic function. We don't call this one is just a function f(x), but this function f(x) is a periodic function due to the period stated in the function. So from negative L to L, so that your period is 2L. So when you have from negative pi to pi, from negative pi to pi, this is just on the f(x) tau. Okay, so this one is just on the f(x), so that you just have only a single function. But the existence of this one, okay, menunjukkan, it shows that you have this function, okay, the previous function, okay, you have this function, but this function will be repeated over the same interval, the same size, the same we call it as the same interval lah, okay, the same interval, so that you will get the function here lah. So the function here, okay, will be repeated each time it travels along the 2 pi. Okay, so from negative pi to pi, so negative pi to 0, you have the distance of pi, and then from 0 to pi, you have another distance of pi, so that you will have 2 pi. So that is why we put here as 2 pi. 2 pi is the period. Okay, so let's try to discuss here. Okay, so macam mana kita nak katakan we have a function and then we have a periodic function. Let me tell you and let me show you. Okay, determine the period of the function and sketch the graph of the function. So we know that the function is defined over the interval, this one, right? From negative L to L, so that your period is 2L. But here, when you take a look at the function, the given function, you have from negative pi, which is your negative L, right? So then it ends at L, which is your pi, so that you will have 2 pi, right? So this is true. 2 pi is your period. So we can say that the period equals to 2 pi. You can just simply write like this. Okay, so now the second question is sketch. Okay, so sketch of the following function. Okay, sketch of the function. Dia tak kata pun over what interval. So dia kata just sketch the graph of the function. So graph of the function, so that you have fx is the y-axis, okay, here. Okay, and then this x is your x-axis lah. So this one. Alright, from negative pi to 0, from negative pi to 0, your y-axis, which is your fx, is 2. So you have this one lah. Remain unchanged from negative pi to 0. Okay, here. Sorry, no, from negative pi to 0, you have 2. So this one. And then, from 0 to pi, from 0 here to here, okay, from here to here, alright, so it is remain unchanged too. So this one. Okay, so this is your function. This is the function, only one single function. But if you can try to extend this function, okay, with the same shape or the same pattern or the same waveform, okay, it is said as periodic function because you have a repeated waveform. So I want to extend this function. I know that, okay, I know that over 2 pi, interval of 2 pi, I will get the same waveform. So this one is 2 pi, this one is, let's say, 3 pi, and then I have 4 pi, and so on. And then I extend to the left hand side, I have negative 2 pi, okay, negative 3 pi, negative 4 pi, and so on. Okay, so that with free hands, I know that this is my original function. Okay, and then I will continue 1 and then go upward. Okay, so continue. Alright, downward. So starting from here to here, okay, 1 unit, and then go up, and then there. Okay, so left hand side, let's say I start from the right, moving downward, and then go to the left, and then I will go upward again. Okay, just copy and paste. Okay, freehand. Okay, so this one. Okay, and then downward, starting from here again, and then to here, go upward, this one to this one, 1 unit, and then go downward, and then starting from here and to the other 1 unit. So this is what we call it as a periodic function. Okay, so it is a repeated function. I hope that you understand this simple example. Okay, so next we proceed to the second one. Okay, so you have a three piecewise function here. From negative 2 to negative 1, from negative 2 to negative 1, your y-axis or your fx is negative 1. So I put it here, negative 1. So negative 2 to negative 1 is here. 1 unit. And then 2 units from negative 1 to 1, so that you have 2 units, okay? So it is equals to your y-axis equals to x. So when I substitute x equals to negative 1, okay, negative 1 here, so fx is negative 1 when x equals to negative 1. So what I can say is the coordinate or the point is this one, negative 1, negative 1. So negative 1, negative 1. Okay, where is the point of negative 1 to negative 1? So like this, right? Sorry. You tak boleh lah nak buat terus panjang macam ni This is because of this is a linear graph. Okay, so that you must understand that this gonna be a linear graph, so that you have the points of negative 1 here, negative 1, negative 1, right? When x equals to 1, so your y is also 1. So the other point is 1, 1. So the other point is 1, 1 here, which is here. So that you can try to take another, the middle point. Let's say when x equals to 0, okay, 0 is within this range, right? So when x equals to 0, I have the other 1 point, okay? So when x equals to 0, your fx is also equals to 0. So this one, the intersection point. So I have more confidence that this is the the graph. Okay, and then the second one, the third one is along 1 to 2. Okay, you have fx equals to 1, fx equals to 1. So you have this kind of graph. Okay, so this is the single function. If you want to try to extend this function, it means that over the period of 4, okay, you will get the same shape of the graph, the same waveform. Okay, so let me try to extend this one. So I have, saya guna freehand, 1 unit and then 2 units and 1 unit. So this one, okay, I have the idea of 1 unit and then go 2 units. Okay, this one you will extend. Okay, 2 units and then 1 unit again. So this one is 3. Okay, so this one is 4 and this one is 5. Okay, this one is 6. So from 2 to 6, it takes 4 units. Okay, so samalah ni, 4 units. Okay, so when you try to sketch to the left, so take it from here, 1 unit, 2 units and then 1 unit, and then go upward, 1 unit, 2 units and then 1 unit. So macam tu. Okay, just freehand, but you must understand that each of 4 units you will get the same pattern of your function. So that is a periodic function class. Alright, so that is how you determine the period, and then how you try to sketch the initial graph. Okay, the initial function. So just write or sketch for this one first according to the given function, and then if you try to duplicate your function of your graph, the graph of your function, so that you just copy and paste according to the period. Okay, and then the shape lah. Okay, so that is how you try, that is the way on how you can try to expand the function. Okay, so next I will continue about the even and odd function. Okay, so in Fourier series, okay, we have even, odd, and another one is neither odd nor even function. I just write it as NONE. Okay, bukan nona zaman sekarang. That is not the one that saya cuba sampaikan, but NONE is neither odd nor even function. Okay, otherwise you can just write it as neither. Okay, so class, for even and odd function, and as well as the neither odd nor even function. So first of all, I want you to understand that for odd and even function, there are 2 ways in order to determine, in order to verify, in order to validate whether you have even or odd function. The first one is by substituting your fx with f negative x. Okay, if it is equals to fx, then you can see that your function is even. The second one is when you plot a graph, and then it is even if the function is if the graph is symmetrical with respect to y-axis. Okay, the second one is about the odd function. Okay, so odd function, you replace fx with f negative x if you get the opposite side, the opposite sign of the original fx, so that is odd function. Okay, and then if you try to sketch a graph, it is odd if the graph is symmetrical with respect to the origin x-axis lah. Okay, so next, about the even and odd function. Even plus even is even. Okay, even function. Odd plus odd is odd. Okay, ini bukan numbers. This is not like numbers. 3 plus 3 equals to 6. That is even, right? Even number, right? So we don't talk about numbers. We talk about function. Okay, odd function with odd function, you will get odd. Okay, kalau awak tak percaya, you can try. Okay, put like this. Okay, is it odd plus odd equals to odd? For example, let's say original function, your original function is 3x plus let's say 2x cube, 2x cube, okay, like this. So when I substitute f negative x, I can say that this one is my function. I say this one is odd. How I know that this one is odd? Because 3 is your x is substitute or replaced by negative x, I will get negative 3x, okay? Negative 3x, right? And then plus 2, here is x cubed, so you have negative x cubed. There you will have negative 2x cubed. So what I can say is this function is odd and this one is also odd, so that the final, this one is also odd, okay? And then my final solution is negative of 3x plus 2x cubed. Okay, so this means that you have negative of original fx, this one, of original fx, so that the result is odd. So it is true, this statement is true. Odd plus odd function equals to odd function. Okay, but odd times odd is even. Even times even is even. Even times odd is odd. Neither times even is neither. Neither times odd is neither. What is meant by neither? Neither means that when you substitute fx with f negative x, you didn't get either fx or negative fx. So that is neither. Okay? And when you try to sketch the graph, the function is not symmetrical about the y-axis as well as not symmetrical with respect to origin. So that is neither function. Okay, so take a look at this one. Determine whether the following functions are odd or even or neither odd nor even function. Okay, so this is very important, class. Cos x, as we discussed in class. Okay, and then you need to replace this one, okay, by using the first way lah. Okay, this one. Kita ada dua cara kan? We have two ways, right? The first one is just substituting fx with f negative x, okay, and then you look whether you have fx or negative of fx. And the second one is, of course, you need to sketch a graph. So now, for the second one, if you don't know how the graph is look like, you can just simply replace fx with f negative x. So this means that each time you find x, you must replace it by negative x. So I will have cos negative x. You must always remember that cosine negative will always be positive of cosine. So this one is equals to cos x. Dia mesti positif. Cosine dia mesti positif. Kalau ada negatif pun, positif kan dia. Okay? Melainkan kalau, unless if you have negative of cosine x, so it can be negative lah. Tetapi cos negative is always positive. Alright. So I find that cos x is fx. Cos x is fx. So I can conclude that this function is even. Why even? This is because of f negative x equals to original fx. This one. Done. Okay. The second one is about fx equals to sin x. Fx equals to sin x. Then I replace x with negative x. So I will have sin negative x. Sine and cosine are different. Okay. Sorry, excuse me. Alright. So for sin negative x, for sine negative x, it will always be negative sine of x. Negative sine of x, I can say that you have negative of original function. Okay, so when I have negative of original function, I can conclude that this function is odd. This statement. From this statement. Okay, odd. Alright, so the second one is This one. I know that x cube is odd. Okay, and then cos square. Cos will always be positive. So this one is even. Okay, so that odd times even, the result is this one. Odd times, okay, odd times even, the result is odd. So I can say that this one is initial guess I say that this one is odd. Betul ke tak? Okay, so kita tengok. Fx is x cube cos x square. So I replace this one by negative x. So I will have negative x cube. Sorry. This one is also cos x, and then this one is negative x square. Negative x cube is negative x cube. Cos negative will always be positive. So cos x square, still the same thing. So now this one is actually negative of original function fx. Okay, negative of original function. Okay, so that negative of original function equals to odd function. So this statement is true. This one. Okay, so the rest will follows lah. Okay, so for this example, you can try. Okay, this one is even. Okay, this one is even, and this one is odd. Okay, so even plus odd, what do you get? Okay, so from this one, you get the idea. Even plus odd, even plus odd, even plus odd. Ada tak? Even plus even, odd plus odd, even times even plus odd. Okay, even plus odd dia tak ada. So that you need to determine dekat sini. So this one is even. Okay, this one even, and this one is odd. So check whether you have equals to original fx, or negative of original function, or neither odd nor even function. Okay, so next for this question, you need to try to expand the function first, and then multiply it with exponent. Check whether you have odd, even, or neither odd nor even function. Okay, so that is one way, the first way, okay, on how you can determine whether you have odd, even, or neither odd nor even function, just by substituting fx with f negative x. The second way, okay, in this video I will show you about the until up to odd and even function, or neither odd nor even function, until how we sketch the graph. Okay, in the next video we will discuss on how the formula looks like, and then how to compute the function. Okay, so we continue. So determine whether the following functions are odd, even, or neither odd nor even function. Okay, so now class, when you are given a piecewise function, it is better if you can try to sketch the graph. Okay, so we choose to sketch the graph lah. Okay, so now I have fx equals to negative 2. X from negative 1 to 0. From negative 1 to 0, I have fx equals to negative 2. Remain unchanged. So like this. Okay, this is the first line. The second line, the second function is from 0 to 1. From 0 to 1, your fx equals to 2. So this one. Okay, lelok sikit lah. Okay, even though dia kata sketch je kan. So this is your x, and then this is your fx. Okay, so now I have these two lines. Okay, so the distance here is 2 units. This also 2 units. This one is 1 unit. This one is also 1 unit. So the same unit. And then when I try to fold this graph, okay, let's say lah, I try to fold over this one at this axis, and then I bring it to upward here. Okay, and then I notice that my right hand side is this graph, but my left hand side is another similar graph, but at the opposite side. Okay, so saya lipat dapat sama tetapi at the opposite side. So this one is type of odd function. Otherwise you boleh lipat dekat sini pun tak apa. Okay, and then you can try to fold around this line pun tak apa, as long as you fold at the origin. Okay, so you will get the um, the odd function. The odd function ni dia punya special dia lagi satu is if you try to rotate, okay, dalam 180 degree if I'm not mistaken, so about 180 degrees you will get the same shape of the graph. So that is another kind of that is another way to say that you have odd function. Okay, so next we proceed to this one. Okay, from negative 2 pi to negative pi, okay, and then from negative pi to pi, from pi to 2 pi, 1 unit, 2 units, and another 1 unit. So fx from negative 2 pi to negative pi, so you have 2 pi. So this is the graph. And then from negative pi to pi, you have x square here. So you have x square, something probably like this. Okay, and then negative pi square, x square, and then you substitute here so that you will have pi square. Okay, pi square. So pi square, what about the pi square class? Pi square is about, this is not from 2 pi lah. So dia akan this one. So I try to this one. I try to show you on how to sketch this one. So your fx equals to x square, okay, within negative pi to pi. Okay, when my x is negative pi, I substitute here. So negative pi square, your fx is pi square. When your x is pi, I substitute here. Juga. Okay, because my x is pi kan, so I will have, when x is pi, substitute here, I will have fx is also equals to pi square. So negative pi is here, and pi is here. And then your pi square is 9 macam tu kan. Okay, let's say lah, kita kata dekat sini lah your pi square, right? So it is something like this. Macam tu lah. Okay, for this one. Okay, and then the last one is, it is equals to 2 pi. Okay, dia substitute sini titik ni dia mati tempat yang sama. Okay, and then here to here is this one. So that I notice that the length here is 1, the length here is 1, and then the length here is 1, and then the length here is 1, and then the shape is just the same. When I try to fold, okay, at this particular axis, okay, at y axis, I find that this one is stick to each other. Okay, it is matched to each other. So this is what we call it as even function. So this graph is even lah. This function is even. Alright. So that is how we try to sketch the graph. So maybe you might ask, what about the neither odd nor even function? So for example, the kind of neither odd nor even function, it can be like this. For example, from negative pi to 0, and then you have another pi. Okay, the first one is from negative pi to 0, your fx is pi, for example. Okay, so something like this. And then from 0 to pi, your function is fx equals to x. So macam ni lah. So graph awak ni macam ni, this one and then this one. So when you try to fold, okay, at y axis, you won't get the even function. Dia tak sama pun, dia tak match. Even you try to fold at these points, okay, along the points of origin, okay, you will find that it is not symmetry. It is not symmetrical about the origin, and this one is also not symmetrical about the y-axis. So that we can say that this is the type of neither odd nor even function. Okay, so that is the end of our discussion about even, odd, and neither or not even function. Okay, from the periodic function, okay, how you can determine the period. Then we go to the even, odd, and neither odd not even function, okay, on how to sketch, and then on how to prove that you have the types of function by substituting f negative x inside your original function. Okay, so that is the end of our discussion. Bye bye.